I suggest maybe, if while we're waiting, maybe someone has some questions. He knew, learned something about YTsaurus, read, something is unclear, some questions, something I want to discuss. You can try to ask it in the chat, and in a couple of minutes that we have, maybe I will answer something. Any questions, not necessarily related to the topic of the upcoming webinar. They are asking how to properly update YTsaurus. Now our best developers are working on writing a Kubernetes operator which will do it. I don't know if I answered the question or not. If you didn't answer, then please clarify, Eugene, what did you mean? Thank you. Let's wait one more minute. You can ask any questions about YTsaurus. If I know the answer, I will answer them. Well, it's 35 minutes, let's start. So, one more question in the chat. Let me answer it, then we'll start. One more question. There are some problems in the documentation. What is the best approach to correcting them? Just write in the chat, or maybe there is a GitHub repo with Markdown. To be honest, I do not know about the GitHub with Markdown. I think we have Andriy here. Andriy, yes, you can fix documentation right in the GitHub repo. You can send us your pull requests. Andriy, now I will send a link on our repo to the chat. Andriy, you can write to the chat, you can self-edit. We really love pull requests, so do not hesitate. Andriy, documentation is our pain. We try to improve it, but in general, it doesn't always work out well. Thank you, Andriy. The link to the GitHub repo will be sent. But in any case, you can always come to the chat, to the general YTsaurus chat. So, let's get started slowly. Hello again to everyone. My name is Dmitriy Ermolov. At Yandex, I work in a team that writes libraries that other developers use in order to work with the YTsaurus. And today I'm going to tell you how to launch your first My application with the help of our libraries and SDK. My story will be arranged as follows. First, I'll tell you in a nutshell what ways there are to interact with the YTsaurus in general. Then we'll talk a little bit about formats, about what ways there are to represent tabular data in our system. And then there will be a big interactive part where we will run operations, watch them break down and so on. I will take periodic pauses in order to answer your questions. So you write them to the chat. If they arise, I will try to answer them in the course of the story. Okay. Probably I have provided all the introductory information. Let's move on to the main part. What are the ways to interact with YTsaurus? We have many different ways. We have our favorite web interface where you can look at the tables, you can do some basic operations there, delete them, read them, run ECL and some other operations. We have a command line client that also allows you to do a lot of things. We have high-level systems such as ECL, ClickHouse over ET, we call it CHIT. Spark over it, which we call SPIT. These systems allow us to describe large computations quite compactly. Let's take a look at the ClickHouse over ET, for example. Here I have raised a test cluster. We can go to the Queries tab. I have some queries prepared here. I launched it. ClickHouse over ET allows you to run some kind of SQL queries on the tables in it. In this case, I filtered out all the entries that are found under the Kennedy line in the name column. There are some tables there. CHIT is a convenient thing, it works quickly, but in some cases it is not enough. Sometimes you want to be able to run operations in some universal generic programming language. And we have libraries that are able to do this on. For the languages Go, C++, Python, and Java. These are the most common programming languages in Yandex, and libraries for them allow you to reach YTsaurus. Well, all other systems are based on one of these libraries in one way or another. There, for example, the Spark over YT works on top of the Java library and ECL, and the ClickHouse over ET on top of the C++. The command line client runs on top of Python and is installed together with the Python library. Okay, before we look at how to work with the library, I want to discuss such a thing as formats. As you all probably know, it is customary to store tables in YTsaurus. And in order to write or read tables, there is such a concept of formats in the system. When you read or write to a table, you specify the format in which you want to receive or give data. Well, an example of this format is JSON. YTsaurus convert data between the format that you said and its internal representation. And thus, the same table can be read in different formats. If you wrote down, for example, a table using the JSON format, does this not mean that you are then obliged to read it only by JSON? No, you can read it in any other supported format. Let's see what our main formats are. And we will look at the example of such a table. There are two columns in this table. There is a name column, where there is a line with the name of some user, and there is a WID column, where a certain number of user IDs. What formats can be used there with a similar or any other table? There are DSV and schemaful_DSV formats. DSV stands for delimiter separators, that is, the value through some kind of separator. The DSV format itself, well, the DSV format is arranged so that we have the column name, equals, and column value. Then tabulation, then the next column name, equals, and column value. Then there is tabulation and so on until the line ends. There one row of the table corresponds to one row. Well, in a text line. The value of the separator, well, that is, this tab character and the table row separator can be configured if required. But by default, the column separator is a tab, the table entry separator is a line feed. Schemaful_DSV omits the column names, that is, there is just the value of the fields. The value of the columns separated by a tab character. And again, one line of text, one row of the table. The separators are also configured here, and we'll see how it's done a little later. The advantages of this format include the fact that they are very simple. Parsing them in simple cases is easy and can be done in absolutely any programming language. If you are writing a script in Bash, then in general it is convenient to use one of these formats. The schemaful_DSV can be exported to Excel. If you set up the separator as a comma, then we get a standard thing of CSV. The disadvantages of this format are that as soon as our data becomes a little less trivial, it starts to be quite painful to work with them. If there are any spaces or the same tabs in our table in the rows there. If there is binary data in the lines, there, for example, you store some small pictures in the table. Then all this starts to work poorly with DSV, with schemaful_DSV. Some of these problems are solved by the following JSON format. I don't think I need to explain how JSON works. Everyone met him one way or another. In the JSPN format, each row of the table corresponds to one JSON dictionary. Different entries are again on separate lines in a row. JSON's dignity is understandable. Everyone knows him. There are stalls in absolutely any programming language. It is usually not difficult to connect them. What are the disadvantages? The main drawback, in my opinion, is that JSON does not support some types of data. For example, if you have again a table with pictures with binary data, then according to the standard, such data cannot be expressed in JSON. JSON is required to contain only valid Unicode strings. In fact, there are different crutches that allow you to bypass this limitation of the JSON format, but accordingly you need to adjust to them. There are no special standards here. Well, these YTsaurus also supports crutches. If you really want to read the table through the picture through JSON, you can do it, but then you will have to dance a little to restore it. The second problem is not the most efficient parsing. That is, the lines are transmitted with quotes. There, the numbers we have in text, so they can take up more space than they could. That's it. There is clearly room for optimization, for improvement. And so we have the following format. This is ESN. YTsaurus is such a JSON for the YTsaurus. It solves part of his problems. In particular, in YTsaurus, there is an efficient binary representation, which is convenient to parse. And parsing happens quite quickly. It has a readable text representation. In a readable textual representation, YTsaurus very much resembles JSON. That is, we have the same strings, numbers, and so on there. And in general, structurally, he really strongly resembles JSON. There are lists, dictionaries, numbers, Boolean strings. That's all there is. According to the syntax, the minor difference is that it is visible on the example on the slide. There, a semicolon is used instead of commas, instead of a colon is equal to. In some cases, the lines cannot be wrapped in quotation marks. Well, the differences are minor. Another advantage of YTsaurus is that it supports all types of YTsaurus. In particular, binary lines are transmitted there without crutches. There we are able to distinguish between signed and unsigned integers inside YTsaurus, which again, JSON cannot do. But there are also disadvantages of this format. Despite the fact that we have a binary representation, this binary representation is still not the most optimal. In particular, in each line we retransmit exactly the columns. Of course, this could not be done. And that's why we still have the following formats. This is SDK and protobuf. These are the most efficient binary formats. Protobuf format allows you to receive, present table lines in the form of protobuf message. In general, protobuf, this is a widespread library for data sterilization deserialization. I think that many of you have come across it in one way or another, or at least heard about it. SDK is our internal development, which in some cases is more convenient than protobuf. I'm not going to show how these formats work. Here it is necessary to read the documentation, and this is actually their main drawback. The fact that it is difficult to work with them without support from the library. Some of our libraries support them there, and it is quite convenient to work with them there. If you are writing some kind of description for yourself from scratch, there in the language, I don't know, Ruby. Then here you will have to work hard to add support for these formats. Well, the advantage is that these formats allow you to transfer the rows of the table as efficiently as possible. At this point, I'll probably take a short pause, and before we move on to the interactive part, I want to answer the questions. Are there any? The question is, what is a SDK? SDK is a binary format. In fact, it's a bit like the open source Avro format, if you've heard of it. Description, if my memory serves me right, they are in the documentation. Let me try to find a browser. I have documentation open here. I'm trying to look for a SDK. Here, there is a SDK format. In the documentation, you can read about how it works. SDK is a format there. Here is a schemafel format. Such a play on words. Okay, if there are no more questions. Since it is very inconvenient to look at the Zoom, then let's move on to the interactive part. So, I have that open terminal. I hope everyone can see. If you can't see it, please write to the chat, and my colleagues will tell me about it there. Let's try to apply our knowledge and read some table. I actually prepared this table. Let's go to the web interface, find her. Here, read example. Here we have this table, and let's try to read it in the DSV format. I will be reading from the command line client. YT. It's called the client. It is installed together with the Python library. A little later I'll show you how it's done. But let's try without further ado. Let's try to read something. So, in order to read it, I need the address of my YTsaurus server. In general, it can be specified through this environment variable. That is, I have this variable environment set up, and therefore any T command will correctly access this particular cluster. But also this environment variable is possible. An indispensable environment, the address can be specified via the proxy command line option. I work with many clusters at work, so I usually manually specify a proxy, but within the framework of this example. This story, I will rely on a variable environment. This is how we will always work with our test cluster. Okay, here's the list command by the way. It allows you to get the contents of a directory. Here you can go to the home directory and watch the demo. And here is our red example table, which I will read. Again, until we went further. This is the path in YTsaurus. It resembles paths in Linux or on MacOS, on Unix-like operating systems. The only thing is, there are two here's at the beginning. I'm not going to tell the logic behind this. Just take it for granted for now, or maybe we'll tell you later somehow. Okay. We want to read the table. The table is read using the readTable command. Here we specify the path to the table, and we need to choose the format. Format is specified by the Format option. Pointed, launched, read. Everything is as expected. Let's try to look at the shemafel_DSV format. The shemafel_DSV format does not assume that column names will be written in the values. Therefore, it is, well, the order of columns that we want, we need to record, set initially in the format settings. The settings are set in such angle brackets before the format itself. This is generally a common pattern in YTsaurus, keep in mind. So, we want to have a name first, then a WID. It seems so. Yes, we got it. There are no columns, just the value of the separated stages with a tab. If we want to change this tab here to, say, a comma in order to get a CSV, then, in my opinion, we need to use this option. We specify the value of the record separator and put it in a comma. And no, sorry, it's not a record separator, it's instead a separator for table names. To be honest, I forgot. I forgot. Setting up. I'll look it up in the documentation. Field separator. Setting. If we set the field separator, then we got the CSV. Okay, let's move on. The JSON format gives us the expected JSON and the ESON format. We will be given by ESON. By default, it will be binary. I want to get a beautiful text representation, so I specify the pretty format setting, and here we got a quite readable ESON. You can understand what's going on here. All right. Now let's try to write something down. Let me create a file and try to add another value to this table. Let's have a new person. What will we call him? Let's call him Dmitry after me. And he'll have 14 WID. So, the table is recorded using the write_table command. If I run it like this, it will overwrite the table. I don't want to overwrite the table, so I'm going to add an append equals true to the construction site. I specify the format of JSON and indicate what to read. Well, that is, I redirect the input of this command from the data file. Let's try to run it. Everything is recorded. Now if we read it, we see that a new entry has been added. If we go to the web interface, update the table, then we see it is also there. Well, maybe someone has any questions about what has already been told. Any questions? No questions asked. It seems there are no questions. Then let's move on. Let's try to work with the library now. Let's take a look at the Python library. The Python library can be installed. Andriy, I'm sorry, there's a question there. Answer, please. Is it possible to add one entry? That's a good question. We just finished one record, as I showed. In other words, we just wrote one entry Dmitry. That is, theoretically it is possible. However, in practice, if we add one record to the table, it will create. This creates a lot of load on YTsaurus. Every call of the write_table command. First of all, it requires a trip to the master, and secondly, it creates a separate chunk. And tables with a lot of chunks, for which we have made many such small records, one by one, several records. They will then be inefficiently read. Therefore, if you want everything to work efficiently, you should write to the table with a lot of records. There is one more question. How we came to the notation in triangular brackets. This is why it was impossible to use the usual parameters pairs equal to minus minus pairs equal to XX. Well, that is, let me demonstrate. So, excuse me. That is, apparently it means like this. Well, that's a good question. Actually, let me try to answer it. In fact, all of these parameters are attributes of the object. And here. We have different objects that can have different settings. For example, in this case, we specify that we want to write a table and we arrange some settings on the formats. And if the command is more complex, for example, it is a command to start an operation, then we may have some settings of the input-output tables. And to be honest, here and on equal input-input tables, the settings may be different. Well, it seemed to us more convenient to bind the settings exactly to the object that they configure. Well, syntax annotation in angle brackets. These are actually attributes of our YTsaurus format. I'm not going to focus on them now. This is such a slightly more advanced topic. If we have time left at the end, I may be able to talk about them, if there is interest. But here's a brief summary, so I hope I've added insight. The approach that you are talking about with the -- option for couples, he also has the right to life. But taking into account the abundance of settings, there is an abundance of things that can be configured. Input tables, output tables, formats. It is more convenient to bind. It seems to us that it is more convenient to bind the settings directly to the object in this syntax. Okay, I hope I've clarified something. If I haven't clarified it, then at the end after the main part, we will be able to talk about it again. Okay, let's move on. The YTsaurus library. A library for Python. The Python library is installed with this command. We need two things. This is YTsaurus Client. The YTsaurus package with client contains the main part of the Python code. The command line client is delivered in the same package. That's if. Oh, if you look, then here is YTsaurus is installed in my virtual environment for Python, which. Well, I came with this package. The second library, YTsaurus. It contains a ++ code for working with formats, with YTsaurus there mostly, well, and skiff in fact. And it is needed just for efficient reading, writing of large amounts of data, for launching operations. Without this package, you can do some basic things, list directory there, set some attributes on the table there. Well, if you want to run operations, then these plus bindings are needed for efficiency. Okay, I have two of these packages already installed in a virtual environment. Let's try to look at something on Python. And I have an example for you. This is reading a table. The same thing can be done from Python, the fact that we read the table from the command line client. This is done approximately as follows. First, I'm importing a library. Everything is clear here. Secondly, I am creating a team client to log into YTsaurus. It is created in this way. You only need to specify the address. And then I read. It is read with the help of the read table. The read table takes the path to the table as an argument. Let's try to run it. Here we have read. It is clear that the lines are presented to us simply in the form of Python dictionaries. It's good that we learned the tables. Let's, by the way, maybe modify the code right away. I'll show you how to write it down. The table? If you want to write a table, then you need the write table command. Well, you can also write down ordinary Python dictionaries there. Well, let's add a user Maria with WID, let's say 21. Here we pass, with the second argument, we pass anything, why it is possible to iterate. Let's try to write it down. The recording has occurred. If we update. And, well, yes, here I did not specify the append setting, and therefore the table was overwritten. I could specify the append setting either the same way it was done on the command line. Yes, then it goes to the recording. Or there is actually a Python class that allows you to do this in a slightly more structured way. If my memory serves me right, it's called the table path. To be honest, I haven't written in Python for a while, I might have forgotten something, but let's try to do this. Maybe we can do it. Yes, we did it. Great. And now we have 3 Marias in the table. Okay, read, write sorted out. Let's try to start something now, some operations. As you all know, YTsaurus support MapReduce computing paradigm, and we are going to run operations in this paradigm now. At the same time, I will briefly tell you what it is for those who may not be so familiar with it. So we have a table. The table is arranged in this way. We have a person's name, we have a person's login, and we have some kind of WID number. We are interested in doing the following. We want to get another table that will contain the person's name and email. We will receive the email by a clever calculation. We will be adding at YTsaurus tech to the login. In order to solve our problem, the map operation is perfect for us. And here I have written the code that solves this problem. Let me explain what's going on here. We will be launching the map operation. And actually for this we need to define some custom mapper function. Here it is defined here. The custom mapper function accepts exactly one row of the table as input and can do whatever it wants with it. In this case, I will add at YTsaurus tech to the login. All the same Python dictionaries come to the entrance. In fact, it may not be a Python dictionary, but some more complex object, but it can be treated as a Python dictionary. And at the end, we also have to give out a Python dictionary. The only incomprehensible place, maybe this is the word yield. If someone doesn't know Python, then this thing, which is similar to a return, but allows you to return not one value, but several values from a function sequentially. Let me modify the example right away to demonstrate this possibility. For example, we want to return not one dictionary, not one email, but 2 emails. And we will have the second email for the wrong people. This is how we can consistently return several values using yield in Python. If there was a return, then as in another programming language, we would have come out here on it, and this piece of code would not have been executed. Okay, yes, I'll also say that the mapper function may return nothing. For example, we can filter some values. I do not know, for example, we can filter out all losers who have an even WID. It can return one value, it can return multiple values. There are no restrictions here. The main startup code lives here. Here we create a client, as we have done before. Here we specify the output table. Here we call further, that's the main function of ranmap. It takes the mapper function as the first argument, and then the input and output table. But yes, there is also such a nuance, that when we run operations, we need to wrap the main code here in such a construction if underscore underscore name underscore underscore equals equals underscore underscore main underscore underscore. For those who know Python well, it is probably clear why this is necessary. For those who are not so familiar with this programming language, it allows you not to enter recursion on the server. The server will import this module, and if we don't wrap it, something strange and terrible can happen there. Okay, let's try to run it. If you have any questions, please write them. So far, what's going on? We launched the operation. It's working right now, working. Send the fails. Did I impose it somewhere in the code? But okay, I was planning to show you the fails later. But I'll quickly show them now. Well, yes. Look what happened. The operation began to fail. That's what's going on right now. We launched the operation. The operation worked for a while. What was it doing? It was launching jobs. The jobs tried to process the data that came in, but they didn't process it because of some bug that I created. The system usually operates with huge tables. There is a typical size. There are tens, hundreds of terabytes in Yandex. And it's a shame to lose the progress of calculations if it's some kind of floating problem that will be treated by restarting. Therefore, in this case, the system tried to restart jobs 10 times. But in 10 restarts, my bug didn't get better. I'll have to fix it with my hands. Yes, I got output underscore row and input underscore row mixed up here. And, in fact, that's why the operation failed. There's a lot of logs written here, in fact, so you can figure out what was going on. There's even this exception here somewhere, according to which I understood what was happening. Here it is. Well, in fact, it's more convenient to watch all this in the web interface. I usually do that. If you go to the operation page, then in general it says here the error with which the operation fell. It says here that the number of fallen jobs has been exceeded. That is, 10 jobs fell, too many, the operation was interrupted. The process came out with a non-zero. Well, user job failed, the process came out with a non-zero return code. This usually means a bug in the user code, as I had it now. In order to figure out what was going on here, you need to go to the Jobs tab, find some fallen job. I have them all like that here. And then you can click on the center of this job, and we will see that job send out to center. Here is the usual Python traceback. It shows that the bug is in the 9 line. I've already fixed the bug. Instead of input_row, I wrote an output_row there, and let's try to run it again. If you have any questions, ask, I will answer them. There are no questions yet. Here we have finished the operation. Let's go to the output. Well, yes, and you can see that we have 2 emails for each input value. Unfortunately, I did not print. Well, I did not add the output of WID. But it seems there were some Kennedys in the original table, and they were filtered out. They probably had an even ID. Okay, we took a look at the map operation. Let's now look at the second basic operation of the MapReduce paradigm. This is, strictly speaking, a reduce operation. We'll go to another table. We will have the same table. But no, we filtered on the contrary, only the even ones, right? Oh yeah. Our first one was Sean with an even 1. So now we have another task before us. We want to calculate statistics on how many scenes we have in the company, how many Georges we have, how many Williams we have. Additionally, as part of this, we want to calculate which of the scenes has the longest login there. And here, such tasks are well solved by the operations of reduce. Let's see how it happens. Here I have prepared a second example. And in this example, 2, in fact even 3 operations will be run. The first operation is a mapper. We are already familiar with them. The task of the mapper is to select a name from our table from the column, that is, the name itself without a surname. We will do this simply straightforwardly. Just we split a line by spaces, take the first token. Well, I think there are no problems with the mapper code. We have already dealt with a similar case, so let's move on to the editor. The second part of the reduce operation and the reduce operation are run on tables with a dedicated column key. In this case, the key column we will have here is this created first underscore name column from mapper. The function reducer will accept all rows of the table that have the same column. That is, here in this function, first all the Seans will come there, then all the Williams and so on. And so the function reducer takes two arguments. The first argument is the key. This is the dictionary itself, which stores the key values. In this case, we have one key column. This will be 1, it contains only the first name column. But you can reduce by columns of several keys, and then all the columns that have several keys the same will come here. The second argument of the producer function is the input underscore row iterator. This is an iterator over all the lines that contain, well, which have the same key. And here, in fact, all the basic logic happens. We count the number of such lines and additionally count the longest login. Again, there are no new concepts regarding here. We also spit out the lines using the yield construction. The producer can spit out, he cannot spit out lines. If he does not want to do this for some reason, he can spit out a few. And let's see how it all starts. Everything will be launched here in 3 operations. There will be an operation MapReduce and one auxiliary operation sort. Actually, first we launch the map. We have already seen this. Then, over the heated table, we run the sort operation. The sort operation is needed in order to group columns by key. And the reduce operation should be run on sorted tables. In fact, in this case, you can use another operation. If I forget, please remind me to tell about it later. There is a merged operation MapReduce, but in this case, I wanted to show you how the operation sort command works and launched it. Okay, the sort operation also accepts the input-output table and columns according to which we will sort. In this case, we sort by 2 columns. In fact, this is not necessary, just 1 column is enough. I just wanted to show that sorting is possible not by 1 column, but by several. Operation reduce. A similar operation is launched. We specify the function of the input-output table reducer. Additionally, we need to specify the columns by which we will reduce. The table must be sorted in advance by these columns. In this case, we can reduce either 1 column of the first name, or we can reduce by such columns. Well, the main thing is that this reduce by should be compatible with the sort by. That is, it should be a prefix of the sort by. Okay. I hope I explained something, and it became clearer. If not, ask questions. And we will try to launch it for now. While it's working, I'll watch the chat. How is it done? Are there any questions? There don't seem to be any questions yet. What's going on now? Ah, here comes the question. Do I need to sort by the same field that will be the key 1? Right? Yes, you need to sort by the same field that will be the key, but in addition, you can sort by more fields. Here we have all operations completed here. Let's look at the sorted table. And it can be seen that our table was sorted first by name, and then inside the name, inside all the lines that have one name. It was sorted by login. In other words, the login inside the name is in alphabetical order. And we can reduce such a table either by name, which is what interests us, or by name and login. Well, that is more precisely, the sorting of the table should correspond to it. Should be compatible with those columns according to which we will reduce. In this case, we can sort reduce by just first underscore name or first underscore name and login. We can't, for example, just sort by login. They are simply not grouped by login. I hope this is clear. All right. Good, good. Let's take a look at our output table. Here we have something turned out. Well, there are some results. By the way, it's interesting to see which name is most common in our table. Let's sort this table again to consolidate the result from the command line. Sorting can be run from the command line. So, I need a path. I'll copy it from here. Sort of in my opinion, yes. I will sort the table in place. Now I specify the input table in the SARC, the output table in the dist, and the columns by which I will sort. I specify in the sort by. And if I want to sort by several columns, I can do it. In my opinion, it is indicated like this. Several times the sort by is simply indicated. Let's run this command, but I don't have a name from the column. It's called a first underscore name. And so far I have launched. Well, I've already worked it out. And I wanted to say the following. In this case, we sorted the table in place, that is, the input and output coincided. YTsaurus knows how to do this, and it does it transactionally. What does this mean? This means that when the table is sorted, there will be a new table sorted already along this path. And the most interesting thing is that it will be done atomically. That is, until the sorting has reached. The sorting can run for a long time. If the table there is multi-byte, users will see the old table. When the sorting is done, users will start to see a new table. If the sorting for some reason falls there due to some error, then the old table will not deteriorate. And if there was some user who started reading the old table, at that moment the sorting ran, and the table changed. Then this user will see the old table until the end of his operation, before the end of his transaction. In other words, it will not be that he started reading the old table, but finished reading some new table. No, the data will be consistent, what we started reading, then we will finish. Okay, let's see what we got there. Yes, here we are again seeing how sorting by multiple columns works. First sorted by name inside, by account, then inside the account by name. But we have an ascending sort here. And those who put that the most frequent name we have is Michael, they won. Congratulations. All right. Do you have any questions? Or not? There are no questions, and in fact, I have only one thing left that I want to show you. This is how we run a similar operation in Java API. Here I have prepared an example of our mapper on Java. It takes up more space. Java is such a more verbose language turns out to describe the construction for a longer time, but nevertheless. The library itself lives with us in the package YTsaurus client. Here I used the snapshot version during the preparation for the seminar, for the webinar. We found some problems with our cluster raised there. The fact that the environment there does not correspond to what we have inside in Yandex. We have filled in some fixes, they have not yet sprouted a stable branch. I hope they will sprout soon, and you will be able to use just a stable package. But for now, the second library is needed for logging, so that the logs are described. I think those who know Java understand what kind of library it is. And also such a small remark, that I am not a real Java developer, and I don't know how to write well, Gradle files. So I ask you not to judge me strictly for them. But let's look at an example of an application. In fact, despite the fact that there is more code here, the whole code is structurally similar to what we saw in Python. We create a client, we need to specify the address, and we do it. Then we launch the map. The map is launched in a similar way. We specify the input-output table, and, in fact, the mapper. The mapper itself is set using the class. We need to redefine the function in this class of the map method. The class implements the mapper interface. This interface is parameterized by two classes. Well, in other words, these parameters mean that it will read objects of the eTreeMap node type, and will also spit out objects of the eTreeMap node type. eTreeMap node is an object that resembles a dictionary in Python. In other words, you can also access arbitrary columns here. Inside Yandex, we have some more efficient ways to transfer data. I hope they will become available outside there in some foreseeable future. However, what's going on here? Well, the same thing is actually happening as in Python. We read the input line, we add a at YTsaurus. Tech, we create an output object, where we write the key value and spit it out. I hope everything is clear. If it is not clear, then ask questions. Oh, there are some questions. Great. The only thing I will say is that there are two additional arguments here. They are needed for more advanced cases when we write some statistics from an operation, or use additional information from some context of launching a job there. Let's try to run it all. Now we are uploading the jar files to YTsaurus. Java jars are thicker than the Python ones, and the loading takes a little longer, but usually if you process big data, the loading time is not so noticeable. Okay, we have already, however, the operation has even ended. Here's the results. Actually, it seems to be what we expected. And that's all I wanted to tell you, and I will be happy to answer questions, discuss something. So ask them, please. So, I'm going to chat. Verbose, exactly. Thank you very much. Java is a more verbose language than Python. So, there was another question. Is it possible to run Reduce on Go? It is possible, but, unfortunately, I will not demonstrate it to you right away. I suggest you look at the examples in the documentation. The only thing I will say is the following. Well, such a remark on code delivery. In order to run YTsaurus operation, we need to deliver the user code to our working machines. To do this, well, in different languages, this problem is solved in different ways. In fact, in my experience, the most reliable way suddenly turns out to be in Java. In other words, these are the jars, they are well copied to the server, and then we can easily run them. They are portable, they work from under the MacOS, from under anything. In other systems, in other languages, the situation is a little more difficult. Python can be made to work from under another operating system. Well, that is, we always have Linux on our working machines. Customers often have MacOS, Windows, or something else on their laptops. Python can be made to work in this configuration, but it may be some problem. And in fact, this delivery of code inside Python is such a fragile place. The most trouble-free option is if you run Python scripts from under the same version of Python as on the server, and preferably even from under a similar version of the operating system. Then there will be no problems. If the operating system version or Python version changes there, then there may be problems. And we have a special section in the documentation that is devoted to exactly these problems, how you can try to solve them. There it is necessary to configure which modules we want to copy, which we do not want. There is any non-trivial Python program there, it somehow depends on some kind of C++ modules, predatory modules there. And then there is pain. Inside Yandex, by the way, we solve this pain with Python in a different way. We compile Python into such hermetic binaries that contain a Python interpreter and all dependencies. And now this is being launched with a bang. There are no problems with this, but unfortunately it is not yet available in open source. Here is another question. Is it possible to control the types of compression in the table when writing? Or is it better to leave the decision how to compress to YTsaurus? Thank you, this is a very good question. YTsaurus. There is data compression. Here is the data compression, indicated here by the compression code. By default, this is LS4. This is a codec that works fast enough. Well, that is actually one of the fastest codecs, but it may not compress data very well, especially if the data is binary. It is because it works very fast that it is chosen by our default codec. It has almost no effect on the speed of reading or writing tables, but nevertheless allows you to save disk space. You can control how the table will be compressed. In order to compress the table, you need to set the compression code attribute. This can be done as on. Well, you can do, for example, in the attribute of the table. Let's do the following exercise. I'm going to read this table here, let's say in the JSON format. You already know how it's done. Yes, so I read it. Let's try to write it down. If my memory serves me correctly, the compression code can be specified as follows. Now we need to remember the name of some compress codec correctly. Let's try this compress codec. Let's see what happens. STD_5, this is an algorithm, also an open source algorithm from Facebook, if my memory serves me right. I opened it here in another browser. And it compresses better. I'll do this. I'll duplicate the tab. Look, here we have recorded the same data with a different compression algorithm. This is table with STD_5. This is a table with LS4. It can be seen that STD_5 compressed table better. Compression ration, he has 0.31 against 0.49 for LS4. But such a table will take longer to read and write than the table with LS4. We have a lot of different codecs. I suggest you look at the entire list in documentation. And the second point is that different codecs work completely differently on different data. Some data will be better compressed by one codec, some by another. I won't tell you in advance about this, which code is suitable in your case. We have a utility, in my opinion it is called the Run Compression Benchmarks. Here it is in CLI. Let me take a look. Yes, there are a lot of commands. Yes, this command, it allows you to take your table. It allows you to take this command and your table, run different codecs on it, and see which codec will work better there. If you want to optimize your tables, I recommend you to use this utility. You can read a little bit about her here. There is also a section about it in the documentation. and then experiment with what works best for your data. Any other questions? Oh, here. A little abstract question. Do we recommend YTsaurus or SPIT? It's hard to say what we recommend. These are slightly different tools with their pros and cons. To be honest, I am not an expert in Spark, and maybe someone else will answer better. Maybe Andrew will tell you, maybe we will have several seminars on Spark. If you write in Java, you are used to Spark, then of course you use it. As far as I know, Spark has some restrictions there now. He probably won't be able to reside super large tables there. I do not know there. If you are processing something there in the region of hundreds of terabytes or petabytes, then I do not know. I'm afraid to lie, but for some reason it seems to me that Spark will not survive this. Because it works in a slightly different paradigm than MapReduce. And it seems to be there with the recovery from failures there, from the failure of all sorts of things a little worse. But for many cases, Spark is really convenient. If you are used to it and use it, please. We're all for it. Well, if you write on the C++, then I don't know there. Maybe there is no Spark for them, and it is necessary to run MapReduce operations. Okay, well, you can write either way. Try different things, decide what is more convenient. Are there any more questions? In any case, thanks to everyone who came, listened, and asked questions. Questions are always very interesting. It's very boring to tell if there are no questions. Me, probably. I'll wait. Andrew, a question from Dennis. Andrew, are all operations automatically triggered in a transaction? Andrew, Dennis asks. Yes, all operations are automatically triggered in a transaction. YTsaurus explicitly creates a service transaction in the bowels of itself. The table runs inside it. But you can create a transaction yourself and run several tables in it there. This is also not prohibited. But transaction is such a more complex topic, probably not for this story.